hope you are all doing well. My name is Dr. Amar Kumar De, and I am excited to welcome you to today's lecture titled Introduction to Angle Modulation, Frequency Modulation and Phase Modulation for the course Fundamental of Communication Systems and its Application. It's exciting to see so many of you joining us from different corners of the world. First and foremost, I want to extend a warm thanks for taking the time to be a part of this session. So, without further delay, let us move to the topic titled Introduction to Angle Modulation, FM and PM. Before moving ahead, let us have a quick overview of what we are going to cover in today's lecture, which is titled as Introduction of Angle Modulation, FM and PM. First of all, we start with the introduction. In this, we are going to cover the definition and importance of modulation. In this section, I will briefly explain what modulation is and why it's important in communication system. Then, in the same introduction part, we are also going to cover the types of modulation. I will quickly outline the two major types of modulation techniques, which are amplitude modulation and angle modulation. Since amplitude modulation is already covered, today's focus will be on the angle modulation part. Second, I will cover what is angle modulation. In this, I would like to discuss first the definition and explain how angle modulation involves varying the phase or frequency of the carrier wave. After this, we will also discuss the types of angle modulation, introduce the two types of angle modulations, which are fundamentally frequency modulations, abbreviated as FM, and phase modulation, which is abbreviated as PM. After completing introduction, angle modulation, we will next go to the introduction part. In this, the phase modulation will be covered first. It is commonly abbreviated as PM. Here, we are going to explore the basic concepts, explain how phase modulation works with the phase of the carrier varying according to the amplitude of the input signal. Then, we will have a look on mathematical representation, the basic mathematical formula used for phase modulation. After that, we will discuss applications of phase modulation, such as in digital synthesizers and some digital communication system. I would also like to highlight the historical facts and early usage, mentioning the early usage of PM in analog synthesizer. Finally, I will also cover the modern applications, highlighting its importance in modern digital communication systems like quadrature amplitude modulation. After completing this introduction to phase modulation, I will go to the introduction of the frequency modulation part. The frequency modulation, it is commonly abbreviated as FM. Here, we are going to explore the basic concepts, explain how frequency modulation works with the frequency of the carrier waves varying according to the amplitude of the input signal. Then, we will have a look on mathematical representation, presenting the basic mathematical formula for frequency modulation. Then, we will discuss common applications of frequency modulations and FM radio broadcast. I will also like to highlight the historical facts and inventions. In that, I will highlight the Edwin Armstrong contribution, who invented FM in 1930s. In this section, adaptation and impact, we will also discuss how FM was adopted for high fidelity radio broadcast due to its no noise reduction capability. Next, we will go for the comparison and interesting facts related to FM and PM modulation. In the comparison of frequency modulation and phase modulation, we will discuss the similarities and differences between them. I am also going to cover some interesting facts related to frequency modulation and phase modulation in stereo FM radio, where I will explain how stereo sound is transmitted using frequency modulation, role of phase modulation in digital communication, touch on how phase modulation is used in complex modulation schemes like quadrature phase shift keying and quadrature amplitude modulations. I will also discuss impacts on daily life, relates how frequency modulation and phase modulation affects everyday's technology from radio to mobile phone. Then finally, I will conclude this lecture session, will provide a recap of key points and summarize the key takeaway of this lecture. This content discussed so far will cover the key points related to today's lecture titled Introduction to Angle Modulation, FM and PM, for the course titled Fundamental of Communication Systems and its Application. Now, let us start with detailed coverage of the content. First of all, we are going to discuss our fundamental concepts in communication system, that is called as modulation. To start, let's define what modulation is. Modulation is the process of varying one or more properties of carrier signal, typically a high frequency electromagnetic waves, in accordance with a low frequency information signal. This is done to transmit the information over a distance. But the question is, why is modulation process important in communication system? There are several key reasons. The first is efficient transmission is crucial. By modulating a high frequency carrier wave with the information signal, we can efficiently transmit the signal over long distances. High frequency signal can travel longer distances and penetrate obstacle better than low frequency signals. Secondly, bandwidth utilization is another important factor. Different modulation techniques allows us to make better use of available bandwidth. This is crucial for accommodating multiple signals within a limited frequency spectrum, especially in crowded communication channels like radio and television broadcast. This is crucial for accommodating multiple signals within a limited frequency spectrum, especially in crowded channels, as I already told, in radio and television broadcast. Additionally, modulation helps in noise reduction. Modulation can help reduce the impact of noise and interferences on the transmitted signal. For instance, frequency modulation FM is less susceptible to noise compared to amplitude modulation AM, which make it ideal for high fidelity audio broadcasting. Furthermore, modulation enables multiplexing. Modulation enables the simultaneous transmission of multiple signals over a single communication channel through techniques like frequency division multiplexing, abbreviated as FDM. This increases the efficiency and capacity of the communication system. Lastly, frequency translation is essential in modulation. Modulation shifts the frequency of original signal to a different part of the spectrum. This is essential for matching the frequency range of the transmitted signal with the frequency response characteristic of transmission medium or the receiver. In summary, modulation is a cornerstone of modern communication system. It allows us to transmit information efficiently, utilize bandwidth effectively, reduce noise, enable multiplexing, and translate frequency as and when needed. Without modulation, our ability to communicate over long distance and through various medium would be severely limited. With this understanding of modulation, now let's delve into the specific types of modulation. Okay? We will focus on today the very important type, that is the angle modulation, which includes frequency modulation FM and phase modulation PM. Now that we have defined modulation and discussed its importance, let's quickly outline the two important types of modulation. They are the amplitude modulation, abbreviated as AM, and angle modulation. First, the amplitude modulation. In amplitude modulation, the amplitude or the strength of the carrier wave is varied in proportional to the amplitude of input signal. This types of modulation is common, very commonly used in AM radio broadcast. Okay? In AM, the frequency and the phase of the carrier remains constant, with its amplitude changes to encode the information signal. Secondly, we are going to discuss angle modulation. In angle modulation, it includes both frequency modulation FM and phase modulation PM. In angle modulation, the angular parameter, either frequency or phase of the carrier, is varied in according to the input signal rather than its amplitude. Since amplitude modulation has already been covered in previous lecture, today's focus will be on angle modulation part. We will discuss the specifications of frequency modulation and phase modulation, exploring how they work, their applications, and their historical contents. Angle modulation is particularly significant because it offers better noise immunity and fidelity compared to amplitude modulation. This makes it widely used in various communication systems, including FM radio, television broadcast, and digital communication system. So, let us start by exploring the phase modulation PM in detail. First of all, let us cover the basic concepts related to phase modulation. Phase modulation, it is very commonly abbreviated as PM. It is a technique where the phase of the carrier wave is varied in accordance with the amplitude of the input signal. Unlike amplitude modulation, where the amplitude of the carrier is varied, in phase modulation, the carrier wave's phase is directly influenced by the input signal's amplitude. To visualize this, imagine a carrier wave. In phase modulation, when the input signal changes, it causes the phase of the carrier wave to shift accordingly. This phase shifts encode the information from input signal onto the carrier wave. Now, let us look into the mathematical representation. The mathematical representation of phase modulation can be expressed by this simple equation. It is given by S of t is equal to AC cos 2 pi FCT plus Kp into MT, where the part 2 pi FCT plus Kp into MT is the angular parameter. Here S of t is the modulated signal, A suffix c is the amplitude of the carrier wave, F suffix c is the frequency of the carrier wave, K suffix p is the phase deviation constant, MT is the message or input signal. This equation shows that the phase of the carrier wave is varied by the term K suffix p into MT, which represents the phase modulation. We will have a detailed derivation of this equation in our upcoming sessions. Now, let us discuss some very interesting historical facts and early usage related to phase modulation. Phase modulation has a rich history. It was initially utilized in analog synthesizers, where it allowed musicians and audio engineers to create new sounds by modulating the phase of audio signals. The early usage in music technology laid the groundwork for more sophisticated applications in digital communication. But in today's technology, phase modulation is fundamental to various digital communication systems. One noticeable application is in quadrature amplitude modulation, abbreviated as QAM, which is widely used in broadcast communication system, including cable, modems, Wi-Fi, cellular networks. Quadrature amplitude modulation combines phase and amplitude modulation to increase efficiency and reliability of data transmission, enabling high-speed internet and mobile communication. With this, we have come to an end of the topic phase modulation. I quickly summarize the phase modulation as it is a powerful technique where the phase of the carrier wave is varied in according to the input signal amplitude. Its application range from digital synthesizer to advanced digital communication system, highlighting its versatility and importance in modern technology. This concludes our exploration of phase modulation. Now, let us move on to the next section of today's lecture, which is the frequency modulation. We will also see how it compares and contrasts with phase modulation. So, in today's lecture, now let us turn our attention to frequency modulation, most commonly abbreviated as FM. First of all, let us cover the basic concepts related to frequency modulation. It is a technique where the frequency of the carrier wave is varied in accordance with the amplitude of the input signal. Unlike amplitude modulation, AM, where the carrier amplitude changes, in frequency modulation, it is the carrier frequency that changes to encode the information from the input signal. To illustrate, let us imagine a carrier wave with a constant frequency. In FM, as the amplitude of the input signal increases, the frequency of the carrier wave increases. And as the amplitude of the input signal decreases, the frequency of the carrier wave decreases. This frequency variation effectively encodes the input signal onto the carrier wave. Now, let us have a look on the mathematical representation. The mathematical representation of frequency modulation can be expressed as S of t equal to AC cos 2 pi FCT plus 2 pi Kf integral MT dt. Here, S of t is the modulated signal, AC is the amplitude of the carrier wave, Fc is the frequency of unmodulated carrier wave. Kf is the frequency derivative constant. M of t is the message or input signal. This equation shows that the frequency of the carrier wave is varied by the term 2 pi kf integral mt dt, which represents the frequency modulation part. Now, let us discuss some applications related to frequency modulation. It has a varieties of application, with one of the most well-known being FM radio broadcasting. FM radio broadcasting, in this FM is used extensively in radio broadcasting due to its superior sound quality and resistance to noise and interference. FM radio provides high fidelity audio that is less susceptible to static and signal degradations compared to AM radio. Now, let us discuss some of the very interesting historical facts, its adaptations and impact. Frequency modulation was invented by Edwin Armstrong in the year 1930. Armstrong's work revolutionized the field of radio communication, provides a new method to transmit audio signal with greater clarity and lesser noise. FM was quickly adopted for high fidelity radio broadcast because of its noise reduction capabilities. Unlike AM, which is prone to static and interferences from electrical equipment and weather condition, FM offers a much clearer and more reliable transmission. This made FM the perfect choice for music, high quality audio broadcast. I hope this discussion on frequency modulation has provided some comprehensive overview about the technique frequency modulation, covering its basic concepts, mathematical representation, applications, historical context and significant impact. Let us move for the comparison and some other interesting facts. To wrap up our discussion on modulation, let's compare frequency modulation and phase modulation and explore some interesting facts about their application implementations in our daily life. Let us go for a comparison of FM and PM. FM and PM are both types of angle modulation and share similarities, but they also have some key differences. First, let's talk about the similarities. Both FM and PM vary a property of carrier wave, frequency for FM and phase for PM. To encode the information signal, both offer better noise immunity and high fidelity compared to amplitude modulation system. Both used in various communication systems to transmit information effectively. Now, the key differences are: in FM, the frequency of the carrier is varied according to the amplitude of the input signal, while in PM, the phase of the carrier is varied. FM is less susceptible to amplitude noise and interferences, making it ideal for high fidelity audio broadcast. PM can be more complex to implement because the phase shift needed to be precisely controlled and measured. Now, as we covered PM and FM both, here are some interesting applications. First one is stereo FM radio. One interesting applications of FM is in stereo radio broadcast. The stereo FM use a technique called multiplexing to transmit two channels of audio, left and right, on a single carrier wave. The main audio signal, which is abbreviated as L plus R, is transmitted as usual, while the difference signal abbreviated as L-R, is transmitted on a subcarrier frequency, and at the receiver, these signals are decoded and combined to produce stereo effect, allowing listeners to enjoy high quality spatial audio. Next is role in digital communication system. Phase modulation plays a crucial role in digital communication systems also. It is used in complex modulation scheme like quadrature phase shift keying, abbreviated as QPSK, and quadrature amplitude modulation, QAM. Now, QPSK use 4 different phase shifts to represent digital data, allow it to transmit 2 bits per symbol. QAM combines both amplitude and phase modulation to increase the data rate and efficiency of communication system, making it essential for technologies like cable modem, Wi-Fi and cellular network. Okay. Now, let us discuss the impact of PM and FM on daily life. Both phase modulation and frequency modulation has significant impact on our everyday technologies. FM radio is provide high quality audio, entertainment and information to millions of listeners worldwide. Phase modulation, though its role in digital modulation scheme is fundamental to the operation of modern communication system, includes mobile phone, Wi-Fi, satellite communications. These technologies enable us to stay connected, access information and communicate seamlessly across vast distance. In summary, phase modulation and frequency modulation are both essential modulation techniques with distinct characteristics and application. Phase modulation is renowned for its modern digital communication system applications, whereas the frequency modulation is widely used in high fidelity radio broadcast. Together, they play a vital role in the technologies that shape our daily life. This concludes our comparison for phase modulation and frequency modulation and highlights some interesting facts about their applications and implementations. Thank you for your attention. I am happy to answer any questions you might have. This lecture session provides a clear comparison between phase modulation and frequency modulation, highlighting interesting facts about their applications and relates their impact on everyday technologies. Now, as we have covered all the topics of today's lecture, to wrap up today's lecture on angle modulation, let's briefly recap the key points that we have covered. First, we have discussed the importance of modulation in communication system. Modulation allows us to efficiently transmit signal over long distances, making better use of available bandwidth, reduce noise, enable multiplexing and translate frequency as needed. Now, we explored the types of modulation, focused on angle modulation, which includes frequency modulation FM and phase modulation PM. Then we moved into frequency modulation, where we learned how frequency modulation works by varying the frequency of the carrier wave according to the amplitude of input signal. We covered its mathematical representation and common applications, particularly FM radio broadcast. We also highlighted the historical contribution of Edwin Armstrong, who invented FM in 1930s, and discussed how FM noise reduction capabilities lead to its adaptation for high fidelity radio broadcast. Following that, we examined the phase modulation, where the phase of the carrier wave varied according to the amplitude of the input signal. We present its mathematical representation and discussed its application in digital synthesizers and digital communication system. We touched on the early uses of phase modulation in analog synthesizers and highlight its modern importance in digital communication systems like quadrature amplitude modulation. We also compared frequency modulation and phase modulation, discussed their similarities and differences. We shared interesting facts such as how stereo sound is transmitted using FM and the role of phase modulation in complex modulation schemes like QPSK and QAM. Finally, we relate how FM and PM impacts our daily lives through technologies like radio and mobile phone. In summary, both FM and PM are crucial modulation technique that plays vital role in various communication, from high fidelity audio broadcast to advanced digital communication systems. Understanding this modulation technique enhance our ability to design and implement effective communication systems. Thank you for your attentions. If you have any questions or need further clarifications or any topic we discussed today, please feel free to ask. Before we conclude, I would like to take a moment to thank you all for your participation and attention throughout this lecture. Your engagement and curiosity makes this session truly rewarding. I appreciate your dedications to learn and hope that today's lecture has provided you with a valuable insights into the angle modulation, frequency modulation and phase modulation. Please feel free to reach out if you have any questions or need further clarifications on the topic discussed. Once again, I thank you for joining today's lecture. I will look forward seeing you in our next class. Take care and have a great day.